Welcome our next speaker, Seema Prabhu. Seema is the Director of QA at Huddle. She would be speaking on which brand should I test. To know more about her and to see her video interview, please check out the link given below. I would now request Seema to carry on and present her screen.
And welcome, Seema. You guys have met her already in Cafeton. We are very proud to have you with us, Seema. Thank you so much for joining and giving this session for us.
You can see your screen. Yeah.
You can't hear me. Sorry.
Now we can hear you.
You can. Okay, perfect. All right, just give me 1 second. All right, just give me a second until I share my screen.
Sure. While Seema is setting up, just for everyone in the audience, we'd like to let you all know that she comes with 17 years of experience and her focus has been leadership, establishing sustainable progress processes and building high performance team. So it's glad to have Seema along with us today, and she'll be speaking to us on which branch should I test. Over to you, Seema.
All right, am I unmuted? Can you hear me, see me properly now?
Yes, we can hear you and we can also see you well.
Yeah. Perfect. And good morning, good afternoon, wherever you're listening in from. Thank you so much for your time, for investing time to attend ATA GTR, which is very interesting, and also for coming and watching my talk. Big question that I keep hearing often is on which branch should I test? This is also part of interview questions as to where are you running your automated tests? Where are you running your test? And often I hear variety of answers. So I thought maybe I can give a little input about what I think and where should we be testing what. Okay. Let me, 1 second. A little bit of background to what I'm talking. I will be using a lot of words like could, may, but I won't be using something like you should and you have to or you must, because each organization is different and each team structure is different. You have different processes, your maturity levels are very different. So depending upon your circumstances and the context that you're in, you need to follow what's best that works for you. Secondly, I will only be talking about where to test, as in it could be both manual as well as automation, but I won't be talking about the different types of testing, whether it is accessibility testing, where to run your performance test, where to run variety of tests that needs to be run. That's a bigger context, and I won't be able to finish it in the 20-25 minutes that I have. Probably another discussion and another talk next year. All right, so moving on. As kids, we've played this game. I don't know, many of you might be familiar with it. You might have played it. Maybe your kids are playing with it. It's called the combination man drawing game. How it works is, in this game, a group of people come together and a team or a person draws one part of a image, cover it, and then hand it over to the next person. That person has to draw the middle part of the human body or any body, and then cover it, hand it over to the third team, and that person, but when you open it, you'll see an image which is very funny and all different combinations that you'll be seeing, which that's because we don't know what the previous person has drawn. Anyone familiar with it? It's a game that I often play with my daughter, and I'll let you know why I'm talking about it. I played this with my daughter recently, and one of the things we noticed is if you don't know in what order who's drawing and we put it together, we came up with something like this, which is the legs on the top, the body in the bottom, head in the middle. And funny, yes, for a game. That's because we didn't know who was doing what, in what order we were putting it in. Now let's imagine we knew what our end goal is. We know that we want to be drawing a robot, which looks like this. This is what we tell all the teams to draw. Goes separate ways, and then each one focuses on one part of the body, put it all together. Do you think we'll get exactly what we are asking for at the end of it when we put it together? Probably not. You'll still see a robot, but completely misaligned. The necks are not joining together. The neck is not joining, the hands are not joining, the legs are not joining the body. It's misaligned. And this is very familiar, similar to branching. So imagine the three parts are three branches worked on by three different teams. They put it together. If you don't know what the end goal is, you'll probably get an image which looks like what you see in the first image. If you know what the end goal is and you start putting the image together, you will still find some misalignment. And this misalignment is probably because there is no feedback from one team to another. There is no clear understanding of where one ends and the other starts. And when we work independently of each other, the misalignment, what we see, is seen as merge conflicts in coding and also seen as unfortunate software defects that we come across often. So if everyone saw what was being drawn as it evolved, we embrace change as we are evolving, then there's nothing to hide. When there's nothing to hide, it's much easier to come up with a concise solution. Branching is effectively isolating the changes. It's about hiding changes of what the changes that you make on one part is not affecting the other parts of the code. And branching, when it's not implemented correctly, like how you see in the last image, they're really bad, they're expensive. And also from a testing perspective, when you have two branches, which version of the truth are you going to go with? The one that is branched or one that is out in production? We don't know. And sometimes it could be either one, sometimes it could be both. It's usually a combination of both the versions that are there. Does it mean we shouldn't be branching? Let's have a look. Let's have a look at it from a tester's perspective. Usually what we do is we have an idea, we build, engineer it, and then we want it out in production for users to start using it. Now, when the idea is built, testers come in, we are evaluating this idea has been built to some standards. Is it usable by users and is it releasable to production? And we need to evaluate this idea quickly and efficiently as possible en route to production. So better idea, don't branch. This is what we thought earlier. If we didn't branch, what would we do? We would expect one person to be writing the code, doing the idea, go to production. That's not reality, and that's not how things work. Usually we have different teams working on different parts of the code. So when different teams are working, what can we do if we are not branching? In this case, we could write small pieces of code. First, write our test, see it fail, develop little pieces of code, and then see the test pass, and then you put it back into the master head, trunk, whatever call it. Once it's there, it's straight out in production. but there's a problem there too. If our tests are not really strong enough, if we don't have good coverage, if we don't have enough tests or coverage and tests that will test faster, then we can't go from idea to production efficiently at good speed, right? So what do we need? We need a lot of automation. We need to have excellent automation that has good coverage and running with every change that is merged into the main branch. We need to have very good coverage. There's no branching here. It's just cloning from the master, make changes, small changes, put it back. But this also requires is high team maturity in terms of writing automation, running different codes. That leads us to branching strategies and testing. One of them being trunk-based, which I just explained. You work on a single branch, you have high test automation coverage, and then usually this is continuous deployment. You go from idea development and straight into production. We'll talk about release strategy. Hold on to that for a few minutes. I'll come to it a bit later. The other type of branching is release branching. So you have one branch per release. And in here, probably different teams are working on different branches, and each branch is working towards a particular release. So if you have a hotfix, for example, that's a separate branch. A change is done, the defect is fixed. When the hotfix is released, the change is then pushed into all the other open branches that are available. When one release is complete, those changes need to be then merged into the other release branches that are open. Usually we have partial automation in release branching. That's because these are long delivery cycles. And also because they are long delivery cycles, the frequency of deployment is very short. Usually this is seen in if you're like software vendors like Kubernetes, which supports 3 different release versions and also supports hotfixes. In such cases, you need 1 branch per release. It's also seen commonly in waterfall projects or mini waterfall projects, but less seen. More commonly, what we see is feature branching. In feature branching, you have 1 branch, which is still the main line. And then when working on a feature or a bug, you work on faster iterations. You work on small features, you commit the code regularly, and you have partial automation, you have short deployment cycles, and probably it is continuous integration or continuous delivery. Now, what exactly that is and how it affects feature branching and where we test, I'll come to it in a minute. Hold on to that thought. But in feature branching, typically, we run the automation on the pull request. We develop in small chunks. It doesn't take a lot of time to build per feature. So it's about a couple of hours to a week, or maybe part of less than weeks, I would say. Each branch should be open, and then you commit, merge them into the main line, and eventually it goes out to production. But because we are not sending it straight out to production, it's called continuous integration or continuous delivery. Most often we see the use of feature toggles here, and you don't have to finish development. Suppose you're working on a particular feature, then that feature doesn't have to be fully complete before having to release. So where do we test if we're working like this? We have the idea up to production. Then we have different branches, different teams working on different branches. And the problem here is if you don't merge each of the branch quickly enough, if you keep it open for a very long periods of time, then you don't know if the changes that are made in each of these branches are even safe enough to be merged. we don't get early feedback. And the sooner we fix any issues that we find with the new code that's been developed, the better it is. Now, if you want to get early feedback, we want to be using feature branches. So where do we test? Do we test on the feature branch? Do we test on the main branch? Well, we could be testing on the feature branches, test the individual features on its own. And most often we also see that these tests will be using test fixtures, or it could be a test bed that is being used, data that is hard-coded that is being used. So you're not really testing it in the ideal condition of what it looks like in production. So what you're testing on a feature branch may not be a true version of what you'll see out in production. So how confident are you of what you're testing on feature branches? Then we will also need to be testing where it's integrating into the main line, when the feature gets merged into the main line, when the merge request, then you test there as well, right? So which means you're repeating your test. You're repeating your test on the feature, and you're repeating, you don't have to be exactly the same test, but maybe integration test that you're running on the main pipeline. The downside here is testing different versions of code. What you're testing on feature may not be exactly what you're testing on the main line either, because there are different features getting merged continuously. So you're testing different versions of truth here. Now, the point to remember is avoid conflicts because of delayed merging. We want to fix issues sooner, as fast as possible, rather than wait for a branch to merge into the main line and then look at bugs. As much as possible, try to find that in your feature branch itself, because whatever you find afterwards is much expensive and much complicated to fix. So we're just not pushing every code that is being built, every feature that is being built. You're not just pushing it into the main line and it's not going straight into production, like in how we saw in trunk-based development, right? A lot of the code, when it's getting merged, there is also building that is happening, packaging that is happening, different types of tests that are being run. We're running unit tests, we're running integration tests, we're running functional tests, we are writing tests in the feature stages, we are running integration tests on the pipeline as well, and probably we are running automated tests, end-to-end tests on the main line as well. So there's different types of testing that is happening as the features are getting merged, as we're testing on the main pipeline. But is this enough? Is this all that happens? Most often, no, it is not, because this is where continuous integration, continuous delivery, and continuous deployment comes in. Your testing in the feature branch, testing on the main line, up to a certain point can be automated or is automated. If it is automated, where your unit tests, your building, packaging, integration tests running, all of these are automated, and as soon as a merge request is pushed, all these happen automatically, then it is called continuous integration. If there's any manual effort that goes in this process, then we are not doing continuous integration. But after there is a build package and some kind of tests are run, there are times where you will need to put a pause, where you'll have to stop and do some manual testing. Maybe you're testing, you're not confident of the automated test that you've written previous to the dotted line that you've seen. Or it could be that there are loads of flaky tests in the automation that we have run so far, because of which we have to test manually. Or it could be that you don't have enough coverage for the new features that are being built, for the existing features that are there, depending on the type of project. You may not even have a full coverage of tests. So you're not confident that whatever test has run before this is enough and sufficient for you to have confidence to go into production, which means you stop it there. Then there are people, there's manual intervention, people come in, we test. And then after some kind of test, there's another manual intervention where we are ready to deploy to different environments. And then there's another manual intervention where we push it into production. If you're doing any part of this manually, then it is not continuous delivery or continuous deployment. Okay, so if after the dotted line, beyond the dotted line, you could have end-to-end test, a good set of end-to-end test, which is automated. You don't need a manual intervention. And the code that has been built and packaged so far is deployed to different environments, whether it's test, staging. And again, we have automated tests that are running in those test environments. We have automated tests that will run on the staging environment. Then we're doing continuous delivery up to the point where we have not yet released to production. It's the decision to release to production is awaited. Up to that point, if everything is automated, that is continuous delivery. There needs to be a manual intervention to release this to production. So it depends on the team's maturity. What confidence do we have in our automated test, and how much coverage and how flaky or not flaky our tests are. Depending on that, we either have full automation where we can go towards continuous delivery, or we could only have continuous integration where part of it is automated, but the rest is all manual testing that happens. And this is where we test in the test environment. So often when I'm asked which branch, where are you testing? The answer is test environment. Which environment are we talking about? On the feature, on the main line, in the test environment that's deployed? Where are we testing? We're testing everywhere. We're testing right from the beginning. And lastly, continuous deployment. This is where you don't need any manual intervention. From the point the code is written, the feature is merged, the branch is merged into the main line, everything is automated. Your unit test, integration test, the tests that end-to-end tests that need to happen. Even the deployment is automated up to the point where it's out in production and released. That is continuous deployment. Everything needs to be automated, which means we need to have really high confidence there of what we are building. In terms of continuous delivery, the point where manual intervention comes is just press the button to release it to production. And that press the button is not tech decision, it's mostly product decision. Should we send it? Should users be able to see this, or should users not be able to see this? So do we wait till all the feature has been completed to be actually releasing it to production? Each of these feature branches that we're seeing sometimes may not be fully functional. You cannot be fully testing it because it might be partially developed, or your feature could be developed to a certain point, but you want to release it to production so that you can get some user feedback and then bring it into development again for the second iteration, which means in continuous delivery and continuous deployment, you should be able to release features that are not fully developed and it goes out in production. But that's a little uncomfortable because what you're doing is sending out code that is not fully developed, which means it's really worse. There will be a lot of defects. Partial features will be seen by customers. You'll have customers screaming, saying why it's not working. And that's not what we want, right? This is where we have release strategies come in. Give me a minute. This is where we have a release strategy coming. This is where we start making a decision saying, let's separate deployment to release. We deploy to production, but then it's not still available for end users to start using it. There are 3 different types of release strategies. There's dark launch, where we deploy something, a feature, partially developed feature. People are not, end users are not able to see this, whatever you've deployed into production. It's a way that you can get a feature going out live, but then only some users will be able to see it, or maybe it's just your test team who are actually able to use it because it's not visible for end users. Now, it could be that you've built the back end and then there's no front end, so no one else is able to use it. It could be that you've built the front end, but you've not connected it to the other UI. Again, because of that, other users won't be able to use it. So there's some way of releasing the code to production, ability to use it, but it is not visible for end users because we don't want to release half-done features. The next way is branch by abstraction. Now, if you want to be releasing large changes, you want to replace a big module, and that module you cannot just replace at one go. You have to iteratively work on it. Then we release it by branching by abstraction. You have an abstraction of the existing code and we build iteratively. And at some point, you can then make a decision. Should we replace the old module with the new module, or should we have both for some time and then see how it needs to be used? The last option, which is commonly seen, is feature toggling, where we have different features that are being built partially, maybe fully, maybe sometimes. Once it's out in production, we have a switch where we can either have only some users use part of the feature and some users use the other part. We can then switch and make sure the old is not being seen, only the new feature is being seen. Now that is most commonly used, but we could be using both the dark launch along with feature toggle or branch by abstraction along with feature toggle, so you can mix it up and use it as well. But in terms of testing, what are we really looking for here? We're looking to make sure that whatever feature, even if it's half built, even if it's not completely ready, although we are putting it out in production, we want to make sure that these are performing reasonably in production environment. It should be in working condition. Even if end users are not able to use it, the purpose is to get feedback from a small set of users, or even our test team, or it could be our development team. Whoever the end user is, they should be able to use it reasonably in the production environment. That's our main aim, and that's what we need to be testing for. What we also need is to be able to have automated tests. Now, you could be writing tests for these new features, especially for feature toggles, for example. You could write automated test for the feature, and that feature is out in production. Maybe the feature toggle is switched off, so it's not used by any users, but you want to be testing it. So the automated test that we write for the new feature will only run if the feature is enabled. It will not run if it's switched off. So you need to write it in such a way that these tests will run depending upon the switch. Secondly, it's not just one feature toggle we will have. We could be having multiple feature toggles, some of them on, some of them switched off. So your automation strategy should be able to, it should be built in such a way that the tests are able to determine from probably the configuration that has been set up whether the automated test should run or should it not run, depending upon the feature toggle. Then you have maintenance that needs to be considered, maintenance of old test, maintenance of new test. So you have old features, you have new features. For example, if you are testing something which is branch by abstraction, you you have to maintain both old and new until the point that the old has been switched off, which means that's double. So where do we run both of them and how do we run? That's also something that needs to be considered in our strategy. You could be having two different sets, old set of tests and new set of tests, or you could have one framework which will have both the old and the new. Maybe you're using if statements saying if it's this, then run this test. If it's that, then run those tests. But then once the feature has been out released to production, we're not dark launching anymore. We want to put it out for users, or you're using feature toggle and we've decided it's going to be out in production, users are going to use it, so we're going to switch the feature toggle on. Then we have the additional work of going back, review our tests, tidy up the tests, remove old or remove the if statements so that the old one is not used anymore. So these are other tests that we need to think about.
Quick time check, Seema.
Yes, I'm done. I'm just at
Okay.
the end of it. What I'm trying to say is testing is a part of the full process, the CI/CD, continuous integration from the point of a branch being created or not created, like we saw in trunk-based development. You should be testing at regular intervals, different types of tests. Just because we might only be manually intervening in the test environment that's been deployed doesn't mean that test happens only then. Your testing is happening from the moment the code is being written, and that's what you need to look at the big picture. Look at it from the point the code is being created up to the point it is in production, and not just there after production as well, up to the point users are using it. Beyond that, it's observability. That's another topic I won't be covering here. A quick summary, it depends on the maturity of your team, how mature you are, the processes that are being followed, the architecture of the system that you're working with, level of automation that we have, how much can it handle, how flaky is it, how strong is it, how much can you trust in it, what is your confidence in your tests, both manually as well as in automation, and then the coverage of automation. Do we have everything covered? If not, that means there is a manual intervention stage, which means it may not be continuous delivery, or it will definitely not be continuous deployment. That's me talking about which branch should I test. The answer is everywhere. Thank you.
Okay. Seema, in interest of time, we'll just take a short response to one of the questions posted here, because next speaker would be starting in next 2 to 3 minutes.
No problem.
How do we, if there's a question, if feature tests are passed and integration tests are failed, do you think end-to-end testing are essential after merge?
Sorry, if feature test is fast?
It is passed. So suppose if your
Okay.
feature test is passed and integration tests are also passed, do you think end-to-end tests are still essential after merge?
Like I said, it depends on how confident are you in what you've tested. One thing to consider is in your feature branch when you're testing it, you might probably be using test fixtures. You may not be using, you'll be using everything that is hard-coded except the new feature that is being built. So you're only testing the feature in its isolation, and then you're testing it in integration. If you have sufficient coverage of the automation test in your integration, as well as you have thoroughly tested in your feature branch, then you may or you may not require an end-to-end test afterwards. Or if you've not had enough coverage, then you definitely need it at that point. It depends on your confidence on your automation test and your coverage before. An automated test, end-to-end test doesn't have to be manual, right? It can be automated as well. So again, it depends on what kind of coverage you have.
Thank you, Seema, for your time and answering that question. Namita, over to you.
Thank you.
And there are certain questions we were not able to answer. but we'll request speaker to answer them offline. Seema, if you are there on this track, there are one to push if you can answer.
Sure.
Thanks
Thank
so
you.
much.
Thank you, everyone. Thank you very much.
Thank
Thanks,
you.
Seema.
Bye.
Thanks a lot.
Thank you, Seema. It was indeed an insightful session. I would request the audience to give their feedback on the link displayed on the screen or by scanning the QR code.